You have fallen into Event Horizon with John Michael Godier. We're living in a time of incredible opportunity, especially when it comes to growing your money. And a large part of that opportunity is the global fintech market. It's anticipated to grow by 20% over the next 4 years, eclipsing a value of $305 billion, which is perfect timing because with unprecedented volatility and high inflation rates, JP Morgan recently stated that alternatives are no longer optional. And to meet this increased demand for alternatives, these fintech platforms are stepping up, giving people access to investments they would have only dreamed of in the past. And one of them, my personal favorite, offers a unique asset that's been long celebrated as a way to store wealth. In fact, the ultra-wealthy have been using it for decades. And now 85% of wealth managers recommend modern investors do too. But where it's been previously out of our price range, now it can be yours in a few clicks thanks to Masterworks. Masterworks is a revolutionary investing platform that lets you become a stakeholder in multi-million-dollar artworks without needing millions yourself. And since I've started talking about them on the channel, they've been blown away by the response from you guys. Over 2,000 of you have signed up. Each of these 3 paintings Masterworks has sold have returned over 30% net IRR to their investors. Now legally, I have to add, past performance is no guarantee of future results, but 30+% is pretty amazing. If you want to join other Event Horizon subscribers, it's as easy as clicking my special link in the description to skip their waitlist and get started on Masterworks. In today's episode, John is joined by Jacob Haqq-Misra. Jacob Haqq-Misra is a senior research investigator at the Blue Marble Space Institute of Science. As a member of the American Geophysical Union and the International Astronomical Union, his research focuses on understanding the conditions that allow life to survive on Earth and the possibility of detecting signatures of biology or technology on other planets. He also studies the possible futures of life in the solar system. He received his MS in meteorology in 2007 from Penn State University. He received his PhD in meteorology and astrobiology in 2010. He enjoys playing music as a drummer and vibraphonist. He is a member of the psychedelic rock band Mystery Train.
Dr. Jacob Haqq-Misra, welcome to the program.
Thank you for having me.
Now, Jacob, you recently released a paper that is something that I've been interested in a long time, and it's Technosignatures that we sort of thought all this time, enthusiasts of astrobiology, that we'd probably never be able to do. And that is detecting agriculture on an exoplanet. But you found a way. Could you give us an overview of using the nitrogen cycle of a planet to determine if somebody's practicing wide-scale agriculture?
Yeah, absolutely. One of the things with trying to look for evidence of alien technology is we want to find something that's going to last a long time. If you burn a bunch of fossil fuels, but you do it quickly, the chances of us observing that as an astronomy experiment is very slim. But agriculture is something that you could do for a long period of time across the whole planet's history. And obviously, humans have been doing this for these order of tens of thousands of years, if not longer. So the idea is, I ask myself, well, what is the technology of agriculture? Agriculture is more than just putting a seed into the ground. That's a start, of course. But agriculture it's embodied in the fertilizer. We're managing our planet's nitrogen cycle. And so, we can get into the details if you want a little bit, but, in a nutshell, plants, you need carbon dioxide. Everybody learns this in school, hopefully, and plants take CO2 out of the atmosphere and they use the carbon and they release oxygen. But plants also need nitrogen, and we need nitrogen. It's part of our DNA. All living creatures need nitrogen in addition to carbon and oxygen is just the basic food that's the building blocks of our bodies. And so what agriculture the innovation with that is it started just, simple. We think of it as simple, but this was an innovation, taking manure from whatever animals you have around and intentionally putting that in your soil to enrich it, and manure being a source of nitrogen. And you put it in the soil, it gets broken down by microorganisms. Maybe ancient people didn't understand exactly what was going on, but what they got was better food production, a higher productivity in their fields. And so, a little bit later in history, we were able to improve crop productivity even more by doing crop rotation, realizing that nitrogen gets depleted in one field after prolonged, planting the same crop over and over again. And so if you change crops, you plant beans, legumes, something that actually, the biology of the plant is a nitrogen fixer. It pulls nitrogen back into the soil. And so learning how to manage the types of crops you plant to kind of enrich the soil nitrogen. So those were the two innovations that led us, kind of to the early 20th century. And then the big innovation at that point is what we call the Haber-Bosch process. This is the idea that we can tap into the nitrogen in our air. About 70% of the air is nitrogen, and it's hard to get it at. But this is an industrial process where we can just take nitrogen from the air, combine it with hydrogen. It's a high temperature reaction. So it's an industrial process that we weren't able to do until very recently. And we use this to make ammonia, which we can dissolve in water, and you make fertilizer out of this. You can apply the ammonia to our fields. And this technique and variations on this technique is how our planet has been able to grow to billions of people, because we've been able to so significantly increase our agricultural productivity because of this industrial synthesis of nitrogen. So to get to your question, how does this lead us to a bio or technosignature that we could observe? So we're making ammonia. We're spraying ammonia into the fields. The ammonia, some of it gets taken up by plant roots, but you have to put a lot of it out in the fields because that's a really inefficient process. So some of the ammonia just volatilizes and gets back in the atmosphere. Some of it breaks down into nitrous oxide, N2O, that goes up into the atmosphere. Both of those things, ammonia and nitrous oxide, are pollutants, and they don't stick around in the atmosphere for very long. They get rained out, or sunlight hits them and they get broken apart. But we measure these on Earth today from satellites. There's increasing in large amounts of these two gases, and the majority of them are linked to agriculture. So the idea is, because we can see this on Earth, the only reason we can see those two gases on Earth at that abundance is because we're continually doing agriculture, continually spraying our fields with fertilizer. So if we were to see a planet, it's like Earth, that has oxygen, ozone, CO2 on it, and then we also see a lot of nitrous oxide and a lot of ammonia, that would be a really good indication that there's something like this disruption of a nitrogen cycle. They're doing something like the Haber-Bosch process, or at the very least, a ton of manure everywhere. They're doing something to actively manage their nitrogen cycle, because there's not a lot of ways to keep that much ammonia and that much nitrous oxide in the atmosphere for a long time. But we're doing it. So, I think it's worth keeping in mind as we start to search the atmospheres of these exoplanets.
And that's been one of the things within astrobiology, because if you see an Earth, a planet like Earth that has weird oxygen and methane levels, but you add in this signature as well, you can reasonably say that's not geological. That's a civilization. But what size of a civilization? So if somebody's looking at this planet here from, I don't know, 80 light years away, or 10 light years away, something like that, is our signature in our nitrogen cycle visible at that distance, or do we need a much greater population than we have right now?
Right. Well, fundamentally depends on how big of a telescope do they have, but we're kind of exerting a barely detectable signal, for the kinds of telescopes that we have or that we're thinking about building. So, there's the James Webb Telescope, which probably wouldn't do a great job with this, but there's like the next generation of space telescopes, like that are being considered. the bigger the telescope, the fainter the signal you can detect. But as far as something that we're like thinking about doing, you would probably need anywhere from 30 to 100 billion people. We're like close to 8 or so. So hopefully our planet doesn't have that many people, because I think we have some sustainability problems. But maybe we'll figure that out. And if not, I mean, there's no reason hypothetically that another civilization couldn't grow to that level, or that level of energy consumption. It's not that many creatures, but the energy consumption required by 30 billion people is kind of what we're talking about. So it's, you can sort of just imagine what would it take for an advanced civilization to feed itself over long periods of time. And right now we're dealing with growth in our population and growth in our energy consumption. So when I say 30 billion or 100 billion people for Earth, that's sort of a scary thought, because we don't know how to put the brakes on yet. But really what we're talking about is any civilization that's reached a sustainable growth, whatever that level is, 30 billion people equivalent energy use, but you're able to do that indefinitely. And so that's one of the things that I like about this idea of agriculture as a technosignature. It's not dependent on growth. Even though we're growing today, you can stabilize, and you need to still feed yourself. And it's not like combustion of fossil fuels, where you're going to run out of fossil fuels in a few hundred years. We have plenty of nitrogen in the atmosphere. We're not going to run out. You can do the Haber-Bosch process with renewable sources of energy. So this is the kind of thing that you could imagine a large 30 billion equivalent person population on another planet, but they've figured out sustainable development, and they stay about 30 billion people equivalent for a very, very long time. So I think we're barely detectable now, but it's the kind of idea that lets us think about what could be out there.
But one also has to remember that we're we're somebody else's alien civilization, but we ourselves are just a sampling of one. We're all that we know about. But it may be that there are solutions to population growth as one stretches out into their star system and begins to explore space. There may be solutions like multiple planets or things like that. So you could easily think of situations where an alien civilization might terraform an otherwise dead world, like a Mars or something like that, to be an agriculture planet. And this is where we grow the food, and maintains their population elsewhere, in, I don't know, O'Neill cylinders, or, on their original home world or something like that. And they just use, for some reason, a planet just for agriculture. Now, in such an ideal situation, there are other technosignatures involved here, such as the vegetative red edge, that you could look for to see if these analogs, exoplanets, if you will, are also, really there. So this is actually something that you could take further than just a nitrogen cycle. Once you see the nitrogen cycle, you could say, well, we need to look at this in infrared. And that might be where James Webb might be of more use, wouldn't you think?
Well, no, so I totally agree with you on, the red edge tells you if, it could be an indication of photosynthesis on a planet. And so that can be a biosignature. You could look at Earth and find a red edge. So yeah, if we're talking about a planet, some of the colleagues I work with, Manasvi Lingam and others, he calls these service worlds, a planet that's dedicated to an industrial project like agriculture. So yeah, if you had something like that, a terraformed world or a service world, there'd be other things that you would want to look at, and that would depend on how far away the planet is from its star, how much terraforming was required, and things like that. As far as searching for it, I'm excited about the James Webb Space Telescope, because this is one of our first chances to really try to get a good look at some of these planets that are a little bit more Earth-like, maybe one of the TRAPPIST-1 planets. But like you said, so with the red edge, this is an infrared signature. But to look for evidence of ammonia and nitrous oxide, that would also be most likely an infrared signal. And probably these things would be a little too far into the infrared for the James Webb Space Telescope. The James Webb Space Telescope has some mid-infrared capabilities. the question is, how detectable will these species be? So, you don't know until you look, but it's not super optimistic that some of these, mid-infrared technosignatures will necessarily be strongly detectable with the James Webb Space Telescope. Um, so we got to try. We're not going to be able to look at as many targets as we'd like to with the James Webb Space Telescope, as many Earth-like planets. Hopefully we'll get lucky. But the real excitement will come in the generation of telescopes after the James Webb Space Telescope, and which would be able to detect, dozens of these Earth-sized, Earth-like habitable planets. So those are hopefully the ones that will have more capabilities for sort of really characterizing signatures in the mid-infrared.
Yeah, that's what I'm hoping for is LUVOIR, let's build a really big one. Now, you've written on other technosignatures that are based in chemicals. In this case, we're looking at good old anhydrous ammonia, which being from a cornfield state, I know it well.
Right.
But there's also CFCs, and CFCs are a double-edged sword because you can use them to refrigerate and destroy your ozone layer, or they are very efficient greenhouse gases and you can terraform with them. So this seems like something that aliens might use, and it should be a pretty unnatural signal if you see it. Now, could you give us a profile of CFCs as a technosignature?
Sure. Yeah. I mean, as you mentioned, CFCs are an industrial gas. They were banned by the Montreal Protocol. One of the success stories of an environmental political treaty actually having an impact and getting universal buy-in. And it was a pretty clear demonstration of chlorofluorocarbons being responsible for the loss of ozone, especially in Antarctica. But these things they have very long atmospheric lifetimes. They stick around for a long time. And so even though many of the harmful greenhouse gases are no longer being produced, there's still many of them in the atmosphere. They just have lifetimes of tens to even hundreds of years or longer for some of them. So if you observed CFCs in Earth's atmosphere, or if we observe CFCs in the atmosphere of another planet, there's not really other ways that we know that biology makes these things. They're really kind of big, complicated molecules that we use industrial processes to make. And so these again have a lot of their main signatures in the mid-infrared. So if we saw that, it would be a clear, pretty convincing evidence of something like alien pollution if we were to see that elsewhere. But as you say, what kind of alien civilization is going to want all this greenhouse warming to stick around? So this gets into terraforming again. Maybe you're using the chlorofluorocarbons to terraform your planet, or maybe you're a post-biological life form and you don't care about the effect of CFCs on your environment. I mean, you could speculate about that, but the idea that if you saw this, it would make you raise your eyebrows and think that there's something technological going on the surface is the idea.
Now, it would seem to me that this would open up the possibility of a combo. Now, imagine Mars in the far future, and we're terraforming it using very efficient greenhouse gases like CFCs. If you see a planet, an exoplanet that has a thicker atmosphere with CFCs in it than it ought to have because it's the size of Mars and it should have lost it, then it would seem to me you have a very clear technosignature, right?
No, I think that's a great example, right? Yeah, if you saw, especially like you say, let's say there's a habitable planet like Earth in this, conventional habitable zone, and it looks like it has water and oxygen, and then there's this Mars-like planet outside of that habitable zone and has CFCs and a thicker atmosphere. I mean, yeah, you could imagine scenarios where you could infer, strong evidence of something like terraforming.
And especially if you start where it would get really creepy and interesting is if you started seeing clusters of star systems with habitable worlds like this that are all close together.
Right. Well, this is gets into the Fermi paradox. If interstellar settlement is a common thing and not that difficult for advanced, civilizations, then where are they? Why, you could have colonized the galaxy multiple times if you can do so with exponential growth. And so, maybe the answer is there's just little local pockets of the galaxy that have been settled like that. And we don't know. We haven't looked enough yet to be able to rule that out.
Now, to invoke another one of your papers, what happens if it's not exponential and that alien civilizations, as they colonize the galaxy, do it in a way that we don't expect, a non-exponential expansion?
I think you have to do non-exponential expansion, and this even gets into what we were just talking about with farming. If your growth outpaces your ability to produce resources, then that's fundamentally what sustainability or unsustainability is defined as. And so if you're above your carrying capacity for too long, then you collapse. And there's examples, in human history of this, and then hopefully as a whole, we avoid this for ourselves. But you can imagine the same thing at the galactic level. If you colonize the whole galaxy very quickly at an exponential scale, you hit a wall where you have nowhere else to go. And if your whole civilization has to grow in order to continue thriving, then you're kind of out of luck at that point and you collapse. So, at the very least, after the whole galaxy is settled, you have to put on the brakes and stop the growth. So I think what's more likely is, how are we going to figure this out? We have to figure out what our carrying capacity is. That's a hard number to estimate. It's anywhere from 1 to 100 billion people, give or take. It's hard to figure that out. But certainly there's some limit as to how much food we can produce on the planet, how much energy we can produce per person before we grow beyond that limit. And so how far can we expand into space onto first other planets and to other star systems? So, my pragmatic mind says, maybe you can't actually expand past your stellar system. Maybe it's really hard to have interstellar travel and interstellar settlement, but maybe the limit is the whole star system. And so maybe, we can go to Mars and use resources of the outer solar system and things like that. And maybe that's the limit to growth. But maybe not. And so maybe all that's saying is that it's really difficult to settle the whole galaxy really quickly because you run into these limits. And so, maybe there's small pockets where other civilizations have figured out how to settle nearby stars. They're not doing this in this exponential growth pattern, but they're just, doing it within their carrying capacity. And then you move to another star system and you can grow a little bit, but you're not... You have the idea of growth within the carrying capacity in mind from the beginning. And so you could, a slower growth civilization like that would not necessarily have reached Earth, depending on where they started, and we would not have necessarily found them. And so these are the kind of things that they're fun to think about, but, they can help us, in some ways, and think about how to do this search for technosignatures on other planets, where to look, and what kinds of signatures we might want to look for.
Now, one has to ask a question. We have a relatively close star system, Proxima Centauri, and it has apparently exoplanets. And might it just simply be that it's not worth it? In other words, we sit there and we say, well, we got this beautiful Earth, this eyeball world, there's a gorgeous world. And that thing over there is an eyeball world with some liquid water, but it's tidally locked and it just doesn't look all that great. Not great enough to send a bunch of construction materials 4.5 light years to settle. And that might be the simple answer, is that they stay at home because there's just not that many suitable planets. And unless you're really close to another Earth, there's not much point,
Yep, that's totally possible.
Yeah, so that may be the solution to the Fermi paradox, is that space travel is hard and it's not worth it. And it's better to focus on your own planet of origin or your own star system.
That's right. Anyway. I even wonder where we'll go with Mars. I think it's fun to think about. I even have a book coming out this winter about, the settlement of Mars. But I'm kind of agnostic about whether or not we should, develop permanent settlements and cities on Mars. I think we will send people to Mars for sure. That's going to happen eventually. but will it stay limited to, a handful of explorers, astronauts, SpaceX employees, or will we really have, a city with 1 million people on Mars? And I just think it could be the way that we, nobody really lives in Antarctica other than, a handful of small science and worker collectives that do research. There's not a lot of people living at the bottom of the ocean in underwater cities, like some science fiction authors speculated about. I just wonder if Mars will be like that. Like we'll send people there, but I've said this to my wife. Earth is my favorite planet. Like I want to stay here. This is a great place.
It really is. And I liken it to Mount Everest because Antarctica is nice compared to Mars. Right?
That's right.
Antarctica, we can actually breathe in Antarctica. You just need a lot of insulation. But Mars, no. Now, so I think of it in terms of Mount Everest, in that there are plenty of people on this world looking to summit Mount Everest, even though it's often deadly. There are over 100 corpses on that thing. But they still do it because it's there, and there's a certain type of person that will do it, but they always come back down. They don't live up
there.
That's right. You don't build a house on top of Everest.
And most people as a result, are fine not ever climbing Everest.
Yeah, and most people we just stay here and play our video games down here at sea level. Right. So I think that there will be a certain type of person, then there will be a market for it, for going to Mars, but I don't think anybody's going to want to live there. And I think that it'll just prove to be a vacation destination for the foreseeable future. Now, I think it's coming quickly, though. I mean, it seems that SpaceX and Elon Musk have not wavered from their plan to get somebody to Mars and go there. So I think it's going to be fast. I think it's going to happen, but I don't think people are going to stay. And that speaks to the Fermi paradox, of course, because it just may be that the footprint of even a highly advanced alien civilization is very small. And it's possible, I think, that it could even get smaller and smaller as the aliens progress because of things like nanotechnology. And the answer to the Fermi paradox is that aliens are hard to see.
That could be too. Yeah, they could be everywhere and really, really small. Yeah, and then of course there's the inverse that maybe they're really advanced and we're like ants and we just don't perceive anything about them at all. And we could be staring at them, in ways that we have no clue. It could be in dark matter or something. I'm not necessarily saying that's my favorite idea, but just we have no idea what could be out there. And there is that possibility that we would not even recognize a more advanced civilization if we saw it, especially given the fact that it has to achieve a long-term sustainability with its environment. So, the agriculture is an attempt to get at what a signature of sort of a long-term civilization could be. The CFCs, it's a nice idea to talk about, but it's hard to think about how that would be long-lived. Same with combustion. So we maybe don't know enough yet about what to look for a really long-lived advanced civilization.
And the fun thing about the agriculture is that could be forever. In other words, millions of years. Yeah, millions of years of agriculture as a constantly sustained technosignature that they don't have to put any energy in. In other words, it's not a gigantic omnidirectional radio beacon that you have to power with a star. It's just simple agriculture, and it's a byproduct of being alive.
Exactly.
Assuming, of course, that they eat the way we do and things like that. But
it just assumes that they need nitrogen, because you can do whatever you want with it. It's just an industrial process for harvesting the nitrogen. So, and there could be something else like it if you don't want it in the form of ammonia. But if you're talking about like silicon-based life that uses really weird chemistry, then it might be different. But I think there's an argument that even weird life, as long as it maybe likes similar carbon-based organics, the nitrogen is going to be useful. It's a limiting factor for life on Earth. I think it could certainly similarly be a limiting factor for other kinds of organic chemistry elsewhere.
And it also has to be said too that people will always make the argument that you can't know anything about aliens, but I think there are a few things that you can, and one of them is that evolution occurred. because it just doesn't seem like an organism that can think is going to pop into existence in this universe any other way. It's going to take a long period of evolution to get there.
Well, unless you're building a robot and then something had to evolve to build the robot.
Yeah, that's where it gets scary, is that if you start looking at technosignatures and you're able to determine that they're all technological, and I think Seth Shostak has predicted this, that they're all machines. And
yeah, it could be. It totally could be.
Biology is just a stepstone to something else. And then you got to ask, what happened to the biologicals?
And then that gets back to the Fermi paradox. Where's the robots? Then they should be here, maybe.
They should be. Or I don't know, because you could also make the case that a robot may not care. It just may live entirely in its head and just not care about the universe. All it cares about is collecting up resources and computing.
Yeah, it depends what it was programmed to do. I know that a lot of Seth Shostak and some of the other SETI Institute people have thought about robots being the keepers of the long-term beacon. They're like the lighthouse operators on like geologic time scales, and so you have this radio beacon transmitting throughout the universe as like a monument to a civilization that once was, and they're kind of, or any variation of that kind of a theme.
Yeah, there's the idea of the data ohm, where your data, your collective information, your civilization has built up, is your greatest gift to the universe. Right. So you try to preserve it somehow and send it out there, even though you may be gone.
Right, exactly.
Now, again, in these scenarios that we're discussing, we're assuming that the civilization doesn't go extinct. But if you see CFCs in an atmosphere, it could be that they're destroying their world and that they're on their way out, which is possibly our case. We don't know. So do you think that it becomes at some point a necrosignature if you see it?
Well, if you see it, so if they're dead, right, that's a good question that I've thought about. What's the signature of a dead civilization, a graveyard? And a dead one is really difficult, maybe unless you're on the planet doing archaeology. But short of that, to do remote searches for dead civilizations, I think, is really difficult. But if we saw something with CFCs, we saw basically Earth, but maybe with elevated CFCs. Maybe that might make us think that, did we get really lucky and we found a planet just when it was, about to go on an unsustainable trajectory? With astronomy, we kind of have to, at least the first assumption you make is that if you observe something, that it's probably been around for a long time. You could observe something like a supernova that's a transient event, or a gamma ray burst that's a transient event, and that existed in an instant in time. But if you observe a star or a planet in sort of a steady state, where you take you're observing it for many hours or many days or however long, and you're looking at the light curve and whatever the absorption of the gases in this atmosphere is telling you. You could be lucky in finding this civilization, finding this planet just on the cusp of before it goes unsustainable. But the safest assumption is most of the time with astronomy, you're catching things as they are in sort of a long-term average, like they're the typical state for that object. If we found CFCs in a planet like that, we would just, we don't know everything about what a planet can do. We would really have to just start scratching our heads and looking at more information about that planet just to see, is this really just like Earth before it collapses, or is this something else we don't understand?
Now, something like a dying civilization, or let's call them not a dying civilization, but a mitigating civilization. Okay. Do you think it'd be fruitful to look at things like a sun-like star that's older than the sun, type G that's older, and its luminosity is increasing, and it's trying to bake its habitable zone, or formerly habitable zone, so the aliens would then do drastic measures like a gigantic sunshade around their world that might be visible in a light curve, in a Kepler-like light curve. Do you think that we should start targeting in SETI certain worlds like that where a civilization is forced into building some kind of megastructure to survive.
Well, I mean, the idea is certainly, something that we can talk about, and people talk about that for Earth today, megastructures or geoengineering. I mean, in terms of targeting specific systems like that, I think we just still don't know enough about which systems are most likely to develop life and then technology. Because, it could be that, Earth-like planets around G stars are really great for producing technology eventually. It could be that, M dwarf planets are really great and there's a lot more of them. Or, depending on what the odds are, maybe it's a little bit more likely for a G dwarf system, but not by much. And there's a lot more M dwarf systems, and they've been, a lot of them are really, really old. So, it's hard to say which one is. I mean, this is certainly why it's important to do research on these to make priorities. So I guess there's sort of two answers. One is what I'm telling you now is that it's hard to say which types of systems are really going to be the best for figuring out what civilizations are toward the end of their life. But at the same time, the M dwarf systems, these small red dwarf systems, are probably the ones that are going to be easiest to look at with these, James Webb Space Telescope and the upcoming mission. So those, for better or for worse, those are the ones we're going to get more information about. If you're talking about looking at systems with a radio telescope, the way the SETI Institute does, that's a fine hypothesis, but I think it's really hard to say at this point.
I think what would be all right. So my own feeling on this is that if we ever detect an alien civilization, it's going to be something we don't expect. In other words, we'll be studying a pulsar, and all of a sudden we see a technosignature associated with the pulsar. And then we're left with the great mystery of what are they doing? Where were they originally from? They're not from that pulsar, something like that. And that's what I'm hoping for. Just for hopes is that if we do see an alien civilization, it's doing something really weird that we can learn from. Or if they're destroying themselves and they're at a more advanced stage of destroying themselves than we are, again, we can learn something from that observationally. Even if we don't get like a hello message, which we'll probably never be able to decipher. But now, do you think that if we do get a technosignature, and say, let's take the WOW signal, for example, which looked to be technological and it's weird and we still don't, to this day, know what it was. Do you think it's going to be really hard to detect aliens simply because they're so transient and that their signals don't repeat like ours?
Well, that's a great example. Yeah, the WOW signal was, whatever it was a transient signal. And so that made it difficult to figure out what the source of it was. And so, the atmospheric technosignatures we've been talking about, things like agriculture or CFCs or things like that. The idea is to try to find ones that aren't very transient. And so even CFCs are at least in an atmosphere of a planet for some prolonged period of time. It could be tens to hundreds or even longer, depending on, especially if it's terraforming, then it is a prolonged, intentional presence of a gas. Radio signals can be a little more difficult. If a radio signal is not a continuous signal, then it's difficult to verify where the source is. If you just send one signal out into space, it doesn't really matter if somebody picks up that signal, because it's going to be difficult to identify where it came from if they're not able to continually, to find the signal again. So yeah, I mean, again, what we want are what are technosignatures that are long lived, and what are kinds of technosignatures that are unambiguous or have not very difficult to identify as technological. And so radio has that advantage. It could be, fairly, apparent that there's this narrowband radio signal that might be difficult to make with any other known physical process. But are we going to find a repeating radio signal that's really actually convincing to us? And we haven't found one yet. I mean, I think we should keep looking, but haven't found one yet.
Now, we have a handful of candidates stars that are doing something weird that, we have trouble finding a natural explanation for, but we don't want to invoke aliens yet. We're not to that stage on any of these things. And examples would be Tabby's star or Jabilsky's star, which seems to have transuranic elements in it that it shouldn't have, and things like that, and the WOW signal.
Right.
So we have these sort of hints that maybe, but again, this speaks to what you just said. Ambiguity. They're ambiguous. And that begs the question. I mean, are there technosignatures that are just so unambiguous that if we detect one, there it is, and there would be no debate about it. It has to be an alien civilization.
Well, sure, you could imagine one. I mean, suppose a lunar rover, the Chinese have a rover on the moon. I think there was some rock formation they investigated, in fact, that some people had suspected was some artificial technology. And so, yeah, you just walk up, roll your rover up to some structure. If it turns out to be some silicon monolith with electronics on it, and a serial number with characters we don't recognize. I mean, you can imagine something that could be. I don't describe any likelihoods to these sorts of things, but I mean, I think the point is remote evidence is always going to be really difficult and have a lot of uncertainty and ambiguity to it versus a physical object. Let's say there was alien garbage floating around the asteroid belt and you picked it up, and that would be very convincing. Forget about technosignatures for a moment. Just the idea of looking for biosignatures, just evidence of life, even microbial life that just is in a methane atmosphere or an oxygen-based atmosphere or something like that. If the James Webb Space Telescope or the LUVEX future mission were to detect one of an Earth-sized planet in the habitable zone with water vapor and methane and ozone and CO2, scientists would be debating that for decades as to whether or not that signal is robust, and you'd have to have follow-up missions on it. But if you sent a spacecraft there to enter the atmosphere and take measurements, it would be a lot more easier to say what you're really looking at. So in situ measurements, are always more convincing. We have no idea. We keep coming back to the Fermi paradox. Is there alien garbage in our civilization, or has nobody visited here? And if nobody's visited, then we have no hope in getting that sort of in situ evidence.
Now, that's something that strikes me as a very long-lived technosignature. Okay, not so much alien garbage, but alien mining. So somebody passes through the solar system at some point in the last 4.5 billion years and depletes an asteroid of certain materials. And say we find an asteroid that just appears to have been mined. And it's just the tailings. That's all it's, just a big ball of tailings. And all of the, say nickel or iridium or something like that is gone. I would imagine that would last indefinitely, right? I mean, you could detect that billions of years after the operation ceased.
Yeah, I mean, we haven't started asteroid mining yet. I mean, that would be, quite the discovery if an asteroid mining team started operations on an asteroid only to realize that all the good stuff is gone. But it would be quite the discovery. So yeah, we don't know. We have not searched asteroids well enough to know, if asteroids have been mined either by passing through extraterrestrials or robots that are floating through space, or if some of the objects in the asteroid belt themselves are the remnants of alien spacecraft. I mean, eventually a spacecraft would get broken apart into very, very small pieces and dragged to sort of a stable orbit. But these, we don't understand our own solar system's backyard nearly as well as maybe many people think we do. There's lots to learn everywhere. We know some things, but the amount of stuff we don't know is tremendous.
Now, your thoughts on self-replication, the von Neumann probe, and the idea that you could station such a probe, self-replicating probe, in all of the stars of the galaxy if you wanted to, within short order, geologically speaking. So in geologic time, you could do it in millions of years, and boom, everybody's got one. Do you think that an alien civilization would actually do that? Do you think that that's something that is just too fanciful to expect, or could it have happened?
I mean, I don't see any reason why it couldn't have happened. Just it seems like, when I talk to someone who studies AI, there's no theoretical reason why you can't have replicators, and they've worked out the math for it. And I mean, there's some things where I don't like to give my gut sense for, but for this one, my gut sense is, probably not. Like, it's worth thinking about every now and then. What if there were von Neumann probes everywhere? It comes back to the Fermi paradox and why haven't we seen them? And I mean, I just wonder, like, how long can hardware last before it fails? There's always something. I'm a computer guy. I guess maybe that's where my skepticism comes in. That, like, even with self-replication, there's sort of obsolescence with like changing environmental conditions, and there's unintended environmental consequences. Like a cosmic ray shower can disable electronics. There's, I think, a 1% chance. 1% of electronics failures are just random cosmic ray showers today. So I think there's just a bunch of things that could go wrong without. I think robots work well when humans are there to do service on them, but I'm not sure. But that's just my personal opinion. I know people who study AI who think very differently about it.
Yeah, I have to admit a slight amount of skepticism on the matter because of the reasons that you stated. It's hard to keep a machine running for 1,000,000 years without touching it, And I wonder if that, you would need just an unbelievably advanced machine that probably needs to actually be conscious. Which, do you think it's even possible to ever make a machine conscious?
Well, that gets into what is consciousness, and that's a big topic. I don't know that it matters necessarily. I think for the sake of what we want to know for technosignatures is, could you make a machine that sort of has like self-directed goals? And I think it doesn't matter if you call that consciousness or not. Just if the machine can replicate and have self-directed goals, and then maybe do some process of self-repair and improvement, then it's doing a lot of the things that life does and that humans do. And yeah, if you get that far, who knows where it could go.
Favorite solution to the Fermi paradox? What is your gut feeling? And I'll give you mine. I think that intelligence is simply rare, and that, it just doesn't happen very much. And you look at Earth, and we're the only thing that creates a radio signal. So, and it took 4.5 billion years to get to that stage. Do you think it's just that intelligence is a rare, or do you think there's a more novel favored solution?
Well, that could be. So this is one where I don't like to give my favorite approach, but I can tell you what I do think is, I think we're probably not going to see a planet or civilization in that sort of middle stage where it's dying, or it's in this threshold period of not, where is it going to go? I think we're either going to observe a planet where it's got simple life on it and there's no technology, or we're going to observe a planet where there's technology and they've figured out how to make it last over geologic time. I think we're not going to see anything in the middle. And so what I think we have to do then is, build LUVEX and a couple other telescopes too, get better mid-infrared coverage, and search dozens or more habitable zone exoplanets, and see where that distribution lies. Because if most of them have no technology, and we think we're doing the search well, that means that the transition from where we're at to a long-lived, sustainable technological civilization is really, really hard. And it either never happened, like you're saying, or it happened a bunch and they all failed at it and they all collapsed. But if we do that search and we find a bunch of technosignatures everywhere, then they all figured it out. I think the only reason we will see technosignatures is if they figured it out, how to have this long geologic time sustainability with technology. And if we see that, well, that's really encouraging, because that means that there are solutions, at least in theory, to these problems that we have. And whether we can learn from them or not directly, at least indirectly by example, we know that this is a navigable path. So I think that's the reason we need to search, because it'll help us know which way are we going to go.
I think ultimately the answer will come from just centuries of looking, because if you look for centuries actively and you see nothing, well, there's your answer. It must be rare or non-existent.
Or we're
Or
not
if you
looking
find
right.
something, or we're not looking right, or we come across some technology or some better understanding of the areas of physics that we don't currently understand very well, and then we find that they were doing that, I don't know, gravitational wave communications or something like that. So if we see nothing over a long period, or we see something over a long period, they both answer the question basically. So all we have to do is look and continue looking.
If you don't look, you won't answer the question.
That's right. All right, Jacob, we are out of time for today, and thanks for joining us, and I hope you come back sometime next time you release another paper.
Thanks so much for having me.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.